Uh, all right, so this video that was posted by Stephen Greer, it's about how this, I do believe, physicist, he was based, I'm just going to play the video so you can see, but he worked out of the South Pole, where I'm going to go ahead and start the video now, because this is where the interview with the Stephen Greer is, Dr. Stephen Greer is having with Hecker. He's talking about what he has seen and how he, let me play it.
DOMS, which is a digital optical module. The idea is that it's observing the neutrino interaction when it hits the nucleus of an ice molecule down there. That's what it's supposed to be built to do. But I found in the paperwork that each of these DOMs also can transmit up to 2,047 volts per DOM. That makes this a giant, powerful, active phased array system, which I am now doing due diligence to let the world know what that means. And the possibilities list is huge.
Well, so before we go out too far into that, let's deal with the basics here, is what I was wanting you to talk about.
You got it.
I know you were there working for Raytheon.
Yes, sir.
Okay. So let's go through that. You were assigned there for a year working with Raytheon. It was year X to Y. I mean, just, the whole thing before we get into a lot of the technical.
You got it. So from November of 2010, I landed on the ice at McMurdo Station and was rapidly deployed further south to 90 degrees at the South Pole Station. I stayed there for the 365 days. That employment, that time period, I guess, was for the summer season. We had we peaked out at close to 280 personnel at the site in the summer season. The winter season, we went down to 49. And the neutrino detector was something that I was pretty much obligated to go out to every single day. The equipment was so much. This is another thing that I learned that's peculiar, is there's actually so much computer processing equipment. Remember, this is the South Pole Station in the wintertime. My job required me to go out there, and people laugh at me for this and get mad, but I say it. We had chicken wire on a air inlet duct, like a snorkel duct, that the snorkel side went up to and connected to the building, and there was louvers there that were temperature activated louvers. So the processing of these computers made so much heat that in order to cool it down, they were opening the louvers to transfer exterior air in to keep these computers cold. People really, think about that. This is a building it's sometimes minus 80 degrees outside. To think that you need that type of cooling capacity. And that was what my job was to make sure this building wasn't overheating in the middle of winter at the South Pole.
And why don't you describe, I know you've told me before, but for the audience, the size, the depth of the array, how big it was, how far down into the ice it was, et cetera. See, again, I want to get, so people have a visual of what we're talking about here, because otherwise.
So it sounds like, and the thing is, what's crazy is I've seen a video of this. It sounds like it's a huge laser. All right. A huge, think of it like that. That's what I'm gathering. And I've seen videos of, you probably have seen also, because Stephen Greer has posted these videos of a laser beam being shot at UFOs or ETs. And and you can see the beam going, and it's super fast. And it's been shot into space. So, and the UFOs will actually move out the way. And in the beginning of the video, Stephen Greer mentions how he has heard through his connections that Saddam Hussein's Air Force, a lot of them were shot down with this array, powerful array.
None of this makes any sense. So you got to, let's paint a picture of the facility, the size of the array, how deep it was,
and was it operational when you got there, or was it operational later? All that detail.
You got it. So first and foremost, the central facility where all the processing happens is sitting atop the ice at South Pole Station, which is 10,300 feet actual elevation. And that is ice above Earth. So the ice cube drillers first had to go and drill. They would steam drill down and go basically 2 miles down, close to a 32 to 34 inch diameter hole. And they would drop a string cable down with all of these DOMs on it. Each one of those holes was drilled down, and it was drilled in a giant hexagon that covered kilometers of area in a length and width dimension, and then as far as the depth going all the way down close to Earth, at approximately 2 miles down to that. And everything was cabled and went back to the central building where all the processing computer server towers were and all that stuff. And that was the facility that was being accessed every day and made to be chilled.
Now, apparently this was being built and developed by Raytheon. Is that right?
Yes, that's correct. In the season that I was there, which was so fall 2010 was when I arrived. We transitioned. It was right around, I think, January or February that IceCube officially transitioned from construction to operations and maintenance. Same thing with the elevated station itself, actually, that year.
Okay. And the system. What were the people there told about why it was there and what it was doing, allegedly?
The intended purpose for the IceCube neutrino detector was to detect neutrinos through the muon creation, which was when a neutrino coming from anywhere, in any direction, it could be from the other side of the planet, from off planet, through the planet, it doesn't matter. But when any of those neutrinos smashes into the nucleus of the water molecule, which is in the extremely pure ice. There's nothing else in there. So that's kind of why they're doing it, because they know it's a concentration of something specific, which is just pure water. Great product. When it hits the nucleus, there's two things that occur. A blue flash of light, and the neutrino and the nucleus are destroyed, and a new product called a muon is created. The detector is searching for the blue flash of light. So whatever direction it comes from, it would make like a blast through the array, that when it would hit the nucleus, it would be like a reaction through all of the different DOMs, because they're optical modules and they're receiving at that point. On the receiving end, there's just a bloom that shows up in the array. And from that bloom and the amount of light that hits each DOM, they can triangulate the direction from which the neutrino came from. Mm-hmm. I was told that they would then take that information, transmit it to all the different telescopes in the world, and then that would allow them to then look, because they're so curious as to what neutrinos are and where they come from.
Mm-hmm. And so that was what they were telling you, is that this was a observation technology related to astrophysics or astronomy somehow.
Absolutely, that's correct.
Yeah. And what did you discover it actually is used for?
Quite much more. The ability to transmit is a big deal, and I know a lot of people may not necessarily understand what that means. So I want to paint a picture for them. It's one thing to say that, and the government does this all the time. They sidestep stuff. It would be like if somebody walked up to you and they had something you had never, ever seen before in your life, and they're just simply calling it a bullet carrier. It's a bullet carrier. It carries bullets. But if they never told you it's a pistol or a handgun, they're being rather deceptive in what that thing does. And that's the way I now look at the IceCube neutrino detector, is that this is a savagely different device from what I was presented. And I'm trying to express to the world what that means, because it is absolutely a very big deal.
So you're convinced it was also had not only data gathering, but also offensive weapon capability.
I'm absolutely suggesting that is still on the list of things to check into. I'm a firm advocate of Occam's razor, that every possibility is left on the table, and I have to assess each one. And the split second I can negate something as a possibility, I will apply Occam's razor, cut it off, and remove it. But so far, everything that's left on the table is still possible.
No,
there's a lot.
Yes, there is. Yeah, we can get into that in a moment. But I'm trying to stick with the things that are factually happened and observed, and then we can talk about implications and our assessment in a moment. You told me a very interesting thing that happened the instant they switched this system on. The New Zealand event.
I have a high suspicion that this is when it was going active and they were dialing things in, and that they caused the Christchurch accident. That was
you're referring to the earthquake.
Absolutely, yes.
Mm-hmm.
Yep, I believe that they were dialing it in, and there was a high probability that was just misfire.
Mm-hmm. And a side effect. See, one of the things that people, just give a little background, a lot of people have heard me refer in the past of scalar and longitudinal electromagnetic energy, which, just give people, not to geek out too far here, but when you look at a normal light wavelength, there's a wave to it like this, and a laser is coherent light where all the green spectrum is lined up. When you're doing something with the longitudinal scalar waves are actually a point that goes out longitudinally without the wave, and is much faster than the speed of light, literally, and the normal speed of light is still light, it's still electromagnetic field, but it also can be weaponized. So the early one of the euphemisms that are used, you were talking about the euphemism of this being some kind of like a bullet carrier, when really it's a gun. People don't realize that when J. Edgar Hoover was written to by the field agent there in Roswell, the memo we have that's now become the most...
Very interesting. Check it out. Stephen Greer's channel. It is an hour-long video. I wanted to make this quick, introduction to it. Absolutely fascinating.